Hi, Dr. Pat here. We're looking at matrix inversion and calculating the inverse matrix by hand. So we've got the technology. The technology will find the inverse for us really easily, but if you just wanted to know what goes on behind the scenes, then here we go. Okay, so here's the matrix I want to play with. I'm calling it D. I want to find its inverse. Now the key thing that we're looking for is we want to find a matrix that when multiplied with D will actually make 1. And in terms of matrices, 1 is the identity matrix. That's 1 in the diagonals with zeros everywhere else. So that's what we want to create. We want to create a matrix that we can multiply together that makes the identity so that we can use it in our algebra to kind of cancel things out. Okay, so now let's do this. So one of the first steps that we've got to do is we've got to set up the situation by attaching the identity matrix. So I start with the matrix that we're playing with, D, and then I'm just going to kind of expand out this matrix, and I'm just going to add on the identity matrix. Because again, inverses and a matrix will basically multiply to make this identity matrix there. Okay, so that's what we first do. All right, then remember all that Gauss-Jordan techniques that we use? Well, we're going to do that, and our goal, here's our ultimate goal, is to basically create the identity matrix in the front for the first half of this thing, and then the numbers left over will end up being the inverse. Okay, so let's do this now. All right, so in the Gauss-Jordan technique, what we're shooting for here is to make a 1 in the top corner. There are multiple ways of doing this, so I'm just going to do it one way. You can do it your way. Doesn't matter to me. But to make a 1 there, you know what I'm going to do? I'm going to switch rows 1 and 2. By switching rows 1 and 2, I automatically get a 1 up there. So I don't have to do anything fancy. That's what I've done. You could have also switched rows 3 with row 1. You could do it that way. Also, you could multiply row 1 by -1. That's another way of working it. I just happen to go this way because I am super lazy, and I happen to notice that I create my 1 right there, and I automatically get a 0 there for free. So I get a 2 for here. That's why I went with it. All right, our second technique that we want to do is we want to make zeros down here. So we got the 1 in the top left corner there. That's what I want in the diagonal. And then I make zeros underneath it. How to make zeros is you have to combine rows together. So what I'm going to do, I'm going to add row 1 and row 2, and then add negative row 1 to row 3. So technically I'm taking row 3 minusing row 1 if you want to look at it that way. And so that's what we're going to do. I'm going to add row 1 to row 2, and that'll make a 0 there. So that's where that 0 is coming from. -4, and then I'm going to add these two together. That gives me my 1. I get a 1, 1 there. And so just kind of combining those two rows. Now the third row here, I take that first row, I multiply everybody by -1 and then add it. So -1 and 1, 0. Oh, that's a 0 and a 1, so that's why that stays a 1. Then -1 and 1, that would give me, that's a +1. And that -1 down there will give me a 0, so that's why that's coming there. 0, 0, zeros. Okay, and so -1 times this one, added to the 0, that's where you're getting that -1 there. So that's that second row there. So basically, I now have a 1 in the top corner there, and I have zeros underneath. Our next goal is to create a 1 right here in the diagonal. So now I'm in the second row. I want to create a 1. Two ways of going about this. We could multiply this second row here by a -1/4. That'll create a 1 there. Or, hey, how about if we switch rows 2s and 3s? Because once again, if I switch these rows, I can get a 1 where I want it. And then once again, for another twofer, I can get a 0 right there as well. So that one really worked well. So whenever I see these kind of situations, it sure does save me a lot of steps. And so if I could switch rows around, I'm more than willing to do that. And so that's what I've done here. I've switched rows 2s and 3s so that I can create that 1 there in the diagonal. I just happen to get the 0 here for an extra bonus in a way. All right, our next goal is to get, we got the 1 in the diagonal, is to get a 0's top and above it. Well, top and below it, excuse me. So I got the 0 on top, that's covered. I just got to create a 0 here, make this -4 into 0. To make zeros, I'm going to use the row 2 here, going to multiply that row 2 by 4, and then add it, combine it together with that row 3, and that will create a 0 here. And when I do that to all the second row numbers, I multiply by 4, I add to the numbers in the third row, and these are the solutions I get here. So this is now mostly done here because I've got ones in the diagonal, zeros mostly everywhere except for this -1 right here. So let's start working on that puppy. So we're working on that -1 there. And what I want to do is add rows 3 and 1 together. So I'm going to take row 3, add it together to make a new row 1. See, what's nice about the 0 in the front is that it's not going to change this 1 up here. And so that's really convenient that way. So working it this way, all I have to do is focus in that third column. I don't have to worry about anything changing in the first 2 columns because of those zeros there. And so that's what I do. We're going to add these 2 rows together, and hopefully this is what everybody else gets, that 1 and -1 will become 0. And then that 1 and 0, and then -3 and 1, and then 4 and 0. And so now we have our matrices. We're ready to go. So we have now basically calculated our matrix. What we have to do now is extract the matrix. And so that's the second half here. The first half here was just the identity matrix. We've just made it, and now I'm willing to extract the matrix, and this is what we get. Now, to confirm whether this is actually truly the inverse of D, what you want to do is take this matrix, this D inverse, and multiply it together with the original D matrix. So when we multiply these two together, remember that's row times the column, row times the columns all the way across. And so when we do that, row times column kind of things 9 times, basically we get the identity matrix. And there's our confirmation that what I've created is actually the inverse matrix of D. Thanks. Hope this helped. Talk to you later.